Hello, everyone. Good morning, good afternoon, good evening, wherever you are. I am Najmuddin. I work as a architect in Huawei Technologies. I'm also a maintainer of Soda Foundation. Soda Foundation is a Linux Foundation project for data and storage management. This session is about unified heterogeneous storage monitoring. Is Delfin a way forward? Here, I would like to cover some of the challenges and use cases which storage administrators are looking for to solve their monitoring uh, problems in a heterogeneous environment. And how Delfin, as a project, how Delfin is trying to solve this problem by unifying heterogeneity and having Delfin as a common platform for collection and unification of metrics, right? So let us uh, let us see the agenda for today. Um, First, we will just talk about the heterogeneous infrastructure challenges, why we need a unified monitoring and alerting. We will also talk about SODA. SODA is an open data autonomy project, which is an open source unified autonomous data framework that connects data end to end. And then we will talk about a project under SODA Foundation, which is Delfin. Delfin is a SODA project for monitoring and alert. Okay, if you see the in an infrastructure, the challenges are nowadays infrastructure having heterogeneous devices, heterogeneous servers, heterogeneous arrays, heterogeneous switches. You will see your infrastructure with arrays from EMC, arrays from NetApp, arrays from HP, etc. Right? Similarly, you might have a fabric which is a, a combination of Cisco and Brocade. So a combination of these heterogeneous devices are coming together, and this makes the storage administrators or the IT administrators' job difficult to monitor all these devices. So as of now, we have uh, solutions, right? Storage administrators is having challenges in monitoring data structure when the data growth is rapid and it is combined with heterogeneous devices and increased service level expectations. Okay? So there are vendor specific solutions for such needs. Some solutions support other vendors softwares also up to an extent. However, these solutions are not unified, or it is not collaborative or not open, right? So this is the main challenge in today's world. So administrators have different views. One view and one software for managing EMC arrays, one view for managing NetApp arrays, one view for managing Brocade switches, one for systems. Right? Now, from the storage capacity side, if you just take an example or a use case, like why do you need a unified monitoring and alerting platform? Okay? One of the use cases is capacity trend analysis. Trend and forecast reports can help to plan when more storage capacity is required. Like a 3 months trend would tell me when I am going to hit 90% of my storage. Okay. Similarly, I can have a plan for 6 months. Okay. This trend report can be uh, uh, plotted at the storage pool level or storage system level. Okay. So with this trend report, uh, with a unified trend report for my entire infrastructure storage, what I can infer or what I can interpret uh, and what solution I can take from these are I can reassign storage, I can reclaim storage, or I can purchase additional storage. This is one thing, and another one is like um, capacity purpose analysis, right? So here you want to analyze the characteristics of the storage used. How much of my capacity is used for primary? How much of my capacity is used for local replication? How much is used for remote replication? How much is used for protection, like RAID overhead? How much is used for system resource? This all will help the storage administrator to plan, right? Or which array is supplying most primary storage, or which array is supplying most remote replication uh, purpose, right? Or archiving purpose, which array is used for archiving purpose. So these are some of the use cases where storage administrators is looking for consolidated, unified view. Right? And another one is service level optimization. Service administrator want to see when service level are approaching a defined threshold, right? By using a percentage used in different service level, like it can be a diamond or gold or according to the storage backends, right? So basically, the storage service levels are implemented in storage backends by applying some policies. Uh, a unified way of mapping service level would help administrator to optimize and move data to an appropriate storage types. Right? And another use case is spot performance bottlenecks. Performance analysis is another usage where uh, the in a topology of a storage or a SAN or NAS environment, you see multiple components in the data path, right? From host to storage. You see host, HPA, switches, right? And then array controllers, array ports, and then disk, right? So in the topology, there are many hubs you have to pass through, and you need to check all the metrics available from all this platform at one place, and you want to analyze that workload, analyzing it from a single pane of glass and see where is the actual performance bottleneck. Okay? So this can be given only if you have uh, a platform which gives metrics from all the devices at one place. This is one use case. Another one is a unified alert source, right? You might be getting alerts from multiple devices in multiple format, in multiple models, right? Administrator's job will be easy if it is a unified alert model and a consolidated alert report uh, with which he can see how many of my storages are experiencing hardware failure, or how many of my switches or fabrics are experiencing failures from a consolidated view. So yeah, so these are some of the monitoring challenges. Now I'm just trying to just give an overview of SODA I'm not going in detail into SODA because SODA is a foundation which has multiple projects, right? Uh, SODA actually it connects uh, from application to the storage, right? It connects any application platforms to uh, any storage platform. It is a unified control and data plane. So there are multiple areas which Soda Foundation is concentrating on, and one of the area is data storage and data analytics. So I'm going to concentrate on one of the project in Soda Foundation, which is Delfin. Uh, Delfin is a uh, Soda Foundation heterogeneous resource and performance monitoring framework. Right? Um, Soda Foundation has a goal of making a heterogeneous layer for managing data from edge to core. Right? So Delfin is a platform which helps in that journey to provide a platform uh, which can monitor heterogeneous devices uh, using a single layer, right? Single abstracted layer. So the challenge in today's multi-vendor infrastructure are uh, how uh, how we can unify the data model. Every storage system has its own data model, and how we can unify the data models. How can we build different concepts uh, into uh, a single form, and how we can bring different KPIs or different metrics in a unified format, right, across multiple vendors. So these are some of the challenges which Delfin is trying to address. So, so the main requirements of Delfin are like how to unify uh, the data model, right, and provide uh, a single a single pane for accessing different devices. So Delfin trying to unify everything using one platform, servers, arrays, switches, everything you can configure for monitoring, and you can get the metadata of this platform from Delphin. So that is the goal of Delfin, and Delfin is in the journey of achieving that goal. With the currently, it has support from support of storage drivers, like collecting storage metadata. So I'm just going to the architecture of uh, Delfin. So uh, the Soda Delfin architecture, it is the infrastructure manager project. So currently concentrating on monitoring and alerting, right? Some of the requirements which Delfin uh, Delfin is concentrated on is uh, register uh, multiple devices, right? Get a consolidated view of uh, device metadata, query resource information, right? Get performance information periodically. You should be able to configure and get performance information periodically. Get alerts in the form of trap and in the form of pulling alerts, right? You can alert can be two mechanisms. You get notified and you pull alert from the storage, right? So uh, so Delfin is concentrating on both. Like Delfin gets alert from multiple backends, unify it, and push or notify the user with the alert, right? And clear alert uh, from the backends. Okay? So these are some of the some of the use cases which Delphin is trying to solve. Okay? And so if you see the interfaces of Delphin, Delphin provide multiple interfaces. One is a configuration interface. A configuration interface helps user to configure um, storages, switches, or servers for discovery. Right? So you can configure these devices in Delphin to discover. You can also configure alert sources so that alert will be receiving through Delphin. Right? So there are some configuration interfaces. There are some query interfaces. So query interfaces basically you want to query the metadata uh, from uh, from Delphin. Right? So Delphin periodically discovers the metadata and stores in the metadata in metadata DB and uh, performance information in some other time series database. Right? So this information can be queried from Delphi. So for that, query interfaces are there. So another interface exposed to outside is exporter interface. Right? So like exporter is like a pumping mechanism, right? You just configure for the metadata collection, and once you configure an exporter, you don't need to query for the resource to fetch, right? Delphin, as soon as Delphin collects the information, it will push to the platform through an exporter. So what you need is you need to write exporter for your platform. Okay? So if it is a Prometheus, you need to write an exporter for Prometheus. Okay? Like that. So exporter interface is another interface where you can push the data to outside. Another interface is a DB interface, which internally Delphin uses, but the DB can be configured, right? So any ORM based DBs can be configured, and uh, uh, it has to be connected with the DB interface. So these are some of the interfaces. And some of the core modules of Delphin is Delphin has a resource manager. It is basically the API server for all REST requests. For example, registering or updating the database, or trigger the user synchronous calls, right? User want to synchronize uh, the data from backend to Delphin, because Delphin is a middleware in between backend and user. So if you want to synchronize real-time data, so user can synchronize, and resource manager will take care of that synchronization. Okay? Uh, so these are some of the duties of resource manager. Uh, and Delphin also has a Redis to control a distributed lock, right? So simultaneous access of backends can be controlled by using a Redis distributed lock. Delphin also uses message bus um, like RabbitMQ. So uh, the tasks are posted into a message bus, and the task manager will take task from the message bus and process the task. So resource manager basically when a device is registered, resource manager create task for that resource and post those tasks periodically into the message bus. Now, what task manager does is task manager is responsible for managing all retrievals, like basically all resource retrieval, all performance retrieval. This is the duty of task manager. It basically uses the message bus to receive the task. Uh, tasks are basically the tasks are executed by using the drivers. Okay, so and so uh, driver manager and drivers are the heart of or the actual heterogeneity comes there, right? The driver manager is a place where you can plug in multiple drivers from different vendors. You can have a driver for EMC, NetApp, HP, Hitachi, IBM, Fujitsu, or even switch drivers, server drivers, right? So this is the plan. You can have multiple drivers which can plug into your driver manager. Driver manager is kind of um, driver manager is a kind of a bookmarking a bookmarker which keeps the metadata of the drivers and which directs the call to the driver according to the CC. For example, if it is a uh, it is a call to EMC driver, then it directs the call to the EMC driver, right? So uh, that is the duty of driver manager. So the extensibility of the platform comes in drivers. You can add as much as drivers you want, and that is the beauty of this architecture, where it is an open source project where people from different community, different vendors write their own drivers, right? So uh, uh, when people write multiple vendors, it becomes huge, and it becomes Delphin becomes a platform which support multiple devices, right? And another module is alert manager. Alert manager is responsible for keeping alert source information, alert the MIB, SNMP MIBs for processing the traps, and it also have a trap receiver, uh, a trap receiver to receive traps from multiple devices. Alert manager also has a mechanism to pull alert through the drivers, right? So there is a driver interface to pull alert from the backends. So these are some of the tools, modules available in the Delphin architecture. So So this is just an example of a unified data model where um, Delphin is providing. This is a volume data model. You can see this volume data model is common for uh, all the platforms. So when we collect from different devices, it will be fed into a common uh, data model like this. Right? So this is just an example, and yeah. So another big advantages of Delphin is it provides a unified interface for querying the data or for configuring storage, right? So uh, for example, storages, you can register storages, different storages using one interface. You can get all the storages using one interface, v1 storages, right? Similarly, all the storage pools, all the volumes in the infrastructure, uh, and alert, all the get all the alerts source, right? So these are some of the information, interfaces available in Delphin. Yeah. So this is what Delphin is. Uh, Delphin is a way for heterogeneous monitoring and alerting. Uh, uh, this is an open source project which is having a backup from a big community support, right? And yeah, so just wanted to introduce that, and I just wanted to bring out the possibilities of Delphin in managing heterogeneous infrastructure components. That's it for this session, and please give your feedback, and any questions you please post your questions in Slack. We'll be answering your questions. Uh, thanks for joining. Bye.